Last week we talked about the role of H and K in, as well as A, in a quadratic equation. And so today what we're going to do is we're going to take all of these three different pieces and we're going to put them all together. And we're going to look at what happens when we change the sign of A, as well as looking at multiple transformations of a graph. So here we have our parent function again, y equals x squared. But now when we graph negative x squared, we're going to see that what happens is our a is a negative 1. So what's going to happen is we're still at 0, 0, but now instead of going over 1 and up 1 like we normally do, we have our counting method that we were doing before break. 4, 1, 0, 1, and 2. So when we have a equals a negative 1, we're still going over 1, but now we're going down. So essentially we're going to take our y values and multiply them by a negative 1. So now we have negative 4, negative 1, this is still 0, negative 1, that should have been a 4, and negative 4. So now I'm going over 1 and down 1, over 1 and down 1, over 2, 1, 2, 3, 4, over 2, 1, 2, 3, 4. You can also graph this in your calculator. So you can see here that when we compare these, we have what we call we talked about reflections in 7th grade. This is a reflection across the x-axis, where you can see here is our x-axis, that is our reflection line. So whenever we change the sign of A, it is going to flip our graph. So the change to the parent function in number 1 is a reflection over the x-axis, and a reflection is going to be a mirror image. We talked about that in 7th grade. And a reflection, it preserves the shape. So we're not getting, like when we talked about A being greater than 1 or A being between 0 and 1, it's not a stretch, it's not a shrink, it's exactly the same, it's just a flip. So how does changing the sign affect the graph? It's going to be the same shape and size, but a flip over the reflection line. And ours, we're going to have the reflection line be that x-axis. When you get into Algebra 2, it'll be a different line. So a graph may represent more than one transformation. The order in which the multiple transformations are performed is determined by the order of operations indicated in the equation. So let's look at a couple of those. So here we have y equals x squared, and now we have an a of 2, and we have a k of negative 5. So we know that when a is greater than 1, so this is going to be a vertical stretch, and we have a k of negative 5. So that means that we are going to have a shift left 5. So if I was to sketch a picture of this, 1, 2, 3, 4, 5. Instead of my counting principle of over 1, up 1, over 2, up 4 like this, it's going to be skinnier. And it's going to look like that instead of going through the origin. And you can graph that on your graphing calculator as well. So use these here's the graph. I apologize, I didn't go down far enough. So here is our parent function. I'm going to do that in purple. And then the new one I'll do in red. So again, so now we're over here at negative 5. Remember, negative 2, negative 1, 0, 1, and 2 for our counting. 1 and 4. So since A is 2, it's going to get skinnier. So essentially we're taking all of these and multiplying them by 2. So now I'm going over 1, up 2, over 1, up 2, over 1, up 2. I'm not going to be able to go up 8. I mean, I could guesstimate it to here. And we can see that this is in fact a vertical stretch. It is a thinner graph. So if we look at this next one, let's see what happens here. So now A is negative. So this is going to be a reflection over the x-axis, which just means that it's going to open down now. You could even put that concave down. Because A is between 0 and 1, this is going to be a vertical compression. And because the H is 4, it is going to, I'm gonna have to go back. This is gonna shift up 4. So let me go back over here. I apologize. This should, I got my H and K backwards. This is a shift down. I apologize for that. It should be down 5. So when I go back over here, let me fix that for you. So now we're down here. We're still going to count over 1 up 2 and over 2 up 8. I apologize. I got my H and K backwards. So this one is a shift up 4. So if we're going to graph that, we have our parent function. I'm going to do the parent function in red this time because that's what I'm already on. Let me get rid of that dot there. So now we're going to multiply this by a negative 1/2. So negative 2, negative 1, 0, 1, and 2. So if this was 4, 1, 0, 1, and 4, half is going to be a negative 2, negative 0.5, a negative 0.5, and a negative 2. So you can see that it is in fact going down. So it's going to start, let me change my color to purple so we can see the new one. So we're going to start way up here at 4, and now we're going to go to the left 2 and down 2. We're going to the right 2 and down 2. And then we can go to the right 1 and down 1/2 and left 1 down 1/2. So you can see this is wider. It is a vertical compression. Identify the vertex. So the vertex, the HK, our purple, is 0, 4. The axis of symmetry is x equals 0. And then now we have some parentheses. So this is our H. So again, that negative 1/2 is going to be a reflection over the x-axis and a vertical compression. And then remember, insiders lie. So if H is positive 4, this means that this is going to shift, not right, but left. And I did it correctly that time. I apologize for the previous example. So if we are going to do this, we're going to shift left 4. Remember, A is negative 1, so that's going to be multiplying these, excuse me, these are positives. I'm having an issue today, apparently. Negative 2, 1, 0, 1, 2. So when I multiply this, I get the negative 2, I get the negative 0.5, negative 0.5, negative 2. So we're going over 2 and down 2, over 2 and down 2, over 1, down 1/2. And you can see that this is very wide. So our HK now is different. So it was 0, 4 before. Now it is negative 4, 0. Our axis of symmetry is now x negative 4. So what do all of these things do? So the K is going to be a shift up or down. We've talked about that. The H is going to be a shift left or right. And remember, on that one, insiders lie. The absolute value of A, so that is just the A value itself. And remember, absolute value from 6th grade is always positive. This is going to determine if it is a vertical compression or if it is in fact a vertical stretch. The sign of A is a reflection. Okay, it's going to determine concavity, right? I would like you to try number 11. I'm going to have you pause me. So try number 11, A, B, C, and then we'll look at the next piece. So here are my answers. The 2 makes it be a vertical stretch. The HK is a right 4 up 3. Here's our graph. Remember, you're going to multiply those y values by 2. You can also use your calculator. Vertex is 4, 3, and the axis symmetry is x equals 4. The last thing I want to show you is how you can find A. So if we have the vertex is 0, 0, we know that on the parent function. Describe how the transformation can be used to determine the vertex without graphing. So you would look at your HK, okay? That's going to help you determine your vertex. So if we're looking here, our HK is 4, 7. And that's going to be your vertex there. So there's some practice. I'm going to stop here and then I will have a second video on calculating A. I'm also going to talk about this in our Zoom meeting tomorrow.